Hello friends, in this video we shall discuss with respect to previous paper of NTA UGC NET Electronic Science paper which was conducted on 27th January 2025. In this part 2 video we are going to cover from question number 26 to question number 50. In the part 1 video we have already covered from question number 1 to question number 25. If you have not gone to the video, links are given in the description. Also you can click on the I button. Let us move on to the 26th question. See, in the 26th question what they have given is a platinum thermometer as a resistance of 1000 ohms at they have given the temperature 25 degrees centigrade. Given that the temperature coefficient of resistance for platinum material is, see, this term that is a 0.004 per degree centigrade is taken as alpha. Taking linear approximation, find the temperature at which the change in resistance will become 1500. We know that the change in resistance that is denoted by RT, which is equals to R0 into 1 plus alpha times of delta, where delta is the change in temperature, right? Where delta is the change in temperature, right? We have to measure delta. Now what is the value of RT? The value of RT they have specified to be 1500, which is equals to, what is the value of R0? R0 value is 1000 into 1 plus alpha times of delta. But what is the value of alpha, which is a 0.004 times of delta we have to find out. Okay, now look at the things. This 1000 if I am sending to the denominator, it will be 3 by 2. It will be 3 by 2. Now, which is equals to 1 plus this term you will be getting, and the 1 if I am sending on the left side, it will be minus 1, which is equals to 0.004 times of delta. So this is, if I am taking LCM, 3 minus 2 is 1, so it is 1 by 2. So 1 divided by 2 times of 0.004, it is 0.008, which is equals to delta. So what is this value? Which is equals to 125 degrees centigrade. Which option? Option 3 is going to follow. See, like this we can find out. Or if I am rearranging this the above equation, what I'm going to get, delta equals to RT minus R0 divided by R0 times of alpha. So this is another way how you can solve. So what is the value of RT? It is 1500. What is the value of R0? It is 1000. So which is 500 whole divided by, what is the value of R0? It is 1000 into alpha is 0.004. 500 ones, 500 twos, so it is delta equals to 1 divided by 0.008, which is equals to 125 degree centigrade. Option 3 is going to follow. Either you rearrange and you substitute, or directly you substitute and solve, you'll be getting the answer. See, in the part 1 video, in question number 6, while I was discussing, it gone mute. So let me revise this question number 6. Pointing vector P is given by electric field multiplied by magnetic field, and Ampere's law you will be having curl H equals to J. Modified Ampere's law equals to curl H is given by J plus dou D divided by dou T, where J is a JC, which is conduction current, and dou D divided by dou T is a displacement current density. And waveguides, we know that it is going to behave like an high pass filter, and antenna is a radiating device. So the corresponding option that's going to follow is option 3 is correct. 27th question what they have given is, what is the contents of accumulator AL and the status of the carry flag in the case of 8086 microprocessor. They have given some instructions. Now look at the things. The value of AL is 73 and the value of CL is 29. Now they are performing addition of 73 plus 29. The result will be stored in accumulator AL register. See, after addition, they are executing decimal adjust after addition. They are executing the instruction DAA. Now, in the program, they have not specified a 73H. So that means what? Whatever the number you have given, it will be converted into hexadecimal. Now look at the things. 73, if I am writing in hexadecimal, what is the equivalent I am going to get? 73. So here it is a 16. 16 fours 64. A remainder will be 9. So it is a 49 in. It is a 49 in hexadecimal. 49 in hexadecimal. Similarly, in the case of 29, it is a 1D in hexadecimal. 1D in hexadecimal. You perform addition in decimal, then convert back to decimal, you will be getting the answer. Now look at the things. 49 in hexadecimal, and you are going to add 1D to it. So when you add these two things, see, D followed by what? EF, then 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 you are going to get. Now look at the things. 5 and then 1, it will be 6. So this 6 is in hexadecimal. You have to convert back to decimal. So in order to convert back to decimal, how you are going to convert is, look at the things. 6 into 16 power 0 plus 6 into 16 power 1. 16 6 how much? 96 plus 6 into 1 is 6 only, which is equals to 102. AL is going to store a byte of information, nothing but 02, and then the carry flag value will be 1. The carry flag value will be 1. This is one way of solving. The another way of solving is, see, when the number is exceeding 9, you are going to add 6 to it. Now look at the things. 73, you are going to add 29 to it. So 9 is the maximum value that can store in a decimal. Now look at the things. 9 plus 3 is how much? 12. 12 means what? C. 7 plus 2 is how much? 9. Now, what is the thing it says means, see, when the digit is exceeding 9, what you're going to do is, you're going to add 6 to it, and then you're going to add 1 to MSB bit. Nothing but the next higher nibble. So look at the things. C followed by D, E, F, 1, 0, 1, 1, 1, 2. So here you're going to get 2. Now, what is 9 plus 1? It is 10. So 0, 2 will be stored in accumulator register, that is AL. 1 will be stored in carry flag, or 1 will be copied in carry flag. So either of the method you solve, you will be getting the answer. So the corresponding option that's going to follow is option 1 is correct. Able to understand with the things? In the 28th problem, what they are asking is, you are going to find the inverse Fourier transform of del of omega minus omega naught. Now look at the things. See, we know that in the case of x of t, see, x of t transform is what? X of omega. X of t transform is x of omega. Similarly, if you are performing time shifting, nothing but x of t minus t naught. If you are performing, what you will be getting? See, shifting in time domain, nothing but x of t minus t naught in the case of time domain will be exponential in frequency domain, nothing but x of omega into e power of minus j times of omega into t naught. Very, very important. Right? Now look at the things. See, based on this property, if I am further proceeding with the duality, see, in the case of duality, what I'm going to get? See, x of t is given by what? X of t is given by 2 pi times of x of minus omega. 2 pi into x of minus omega. So this is duality property. Again, what is the delta of omega? Delta of omega, what I'm going to get? 1 divided by 2 pi. Delta of t is 1. Delta of omega is 1 divided by 2 pi. So for this, if I'm applying the shifting property, that is del of omega minus omega naught, nothing but a frequency shifting. If I am applying the same thing, I am going to get, that is exponential in the other domain, that is e power j times of omega into t naught divided by 2 pi. The corresponding option that is going to follow is option 4 is correct. For the 28th question, answer is option 4. 29th question, for a transducer, see, a transducer is the one which converts from one quantity to another quantity. In precise, if I want to say, it is going to convert non-electrical quantity to electrical quantity. Whereas the inverse transducer is going to convert from electrical quantity to non-electrical quantity. So A and B is correct. A, B is correct. So which two options I can eliminate? Option 2 and option 3 can be eliminated so easily. Now, data indicating and recording devices are inverse transducer. Yes, they are inverse transducer. Current carrying coil moving or having rotational displacement in the magnetic field is not an inverse transducer, is a wrong statement. So A, B, C is correct. Nothing but which option is going to follow is option 4 is correct. Now look at the things. For this, what we have to find is what is the collector voltage and what is the base voltage. Looking at the circuit, what you will be thinking is this circuit is very much easy. But you try to apply KVL to the circuit, you will go mad, right? Almost I can tell 50% of the students are not in a position to apply KVL. Why? Just because they have given VEE as a negative voltage. Now you please go through the circuit. What is the least voltage? Minus 9 volts. What is the maximum voltage? Ground. Nothing but 0 volts. So the voltage should lie between minus 9 to 0 volts. The voltage of any node should lie between minus 9 volts to 0 volts. So which option I can eliminate? Option 3 can be eliminated. Why? 8.3 you can't achieve, because positive supply itself is 0. Negative supply you are having minus 9 volts. But what is the positive value? It is maximum, it is 0 volts. Maximum it is 0 volts, right? Now look at the things. They are asking us to find the collector voltage and base voltage. So DC quantities they are asking. So can I write the DC equivalent circuit? The moment when I start to write the DC equivalent circuit, how your capacitor is going to behave? How your capacitor is going to behave means it is going to behave like a what? Open circuit. The capacitor is going to behave like an open circuit. The resistance value is 100 kilo ohm. For the transistor to turn on, what is the base to emitter potential? It should be 0.7. Base to emitter potential should be 0.7, right? Rest of the things you write as it is, nothing change. What is the value of RC? 1.2 kilo ohms. 1.2 kilo ohms, and then connect it to ground. So here you try to measure, it is a VC. Here you try to measure, it is a VB. That's it. So the voltage drop across the base is a base voltage. The voltage drop across the collector terminal is the collector voltage. That's it. Now you try to apply KVL to the input loop. See, the current will be flowing upwards. Why? What is the least potential? V, nothing but minus 9 volts is the least potential. So the current starts flowing from ground potential. So this side is positive, negative, like this. Let me apply KVL for the input loop. What I'm going to get is minus IB times of RB minus VBE, VEE, which is equals to 0. If I'm sending these two terms on the other side, or if I'm sending this IB times of RB on the other side, what I'm going to get is plus IB times of RB, which is equals to VBE plus VEE. Now you tell me what is the value of VBE, which is 0.7, plus what is a VEE, which is a minus 9 volts. So what is the value of IB times of RB, which is equals to the base voltage, which is a minus 8.3 volts. What is the value of VB? Nothing but IB times of RB, which is a minus 8.3 volts. So which option? Option A is going to follow. Option A is going to follow. Now, if at all, if you want to find the value of VC, easily you can find. Now look at the things, how to find the value of VC. Now, so from this you try to derive what is the value of IB. IB current is given by, we know that the value of RB is 100 kilo ohms. So if I am writing IB equals to 8.3 divided by RB is 100 kilo ohms, what I'm going to get, the value of IB is 0.083, and anyway RB is in the order of kilo ohms. I'm going to get milliamperes. Very, very important, right? Don't consider with respect to the direction, not at all required, right? Now, what is the value of IC? IC is given by beta times of IB. What is the value of beta? 45 times of, what is the value of IB? 0.083 milliampere. So what is the value of IC? You are going to get 3.735 milliampere. 3.735 milliampere. Now what is the value of the collector voltage, that is VC? So this VC is the difference from VCC minus IC times of RC. But here what is the value of VCC? VCC value is how much? 0. So VC is 0 minus IC times of RC, which is equals to minus, what is the value of IC? 3.735 milli into, what is the value of RC? You are going to get 1.2 kilo. That kilo and milli is going to get cancelled. What is the value of VC? VC value is minus 4.482 volts. Approximately it is minus 4.48 volts. So the corresponding option that is going to follow is option 1 is correct. In 31st question, what they have given is, one of the following can also act as inverse transducer. See, in the option what they have given is electrical resistance potentiometer, LVDT, capacitive transducer, piezoelectric crystal. We know that this piezoelectric crystal, it is going to convert from electrical quantity to non-electrical quantity, as the definition itself says. What do you mean by inverse transducer? Means it is going to convert from electrical quantity to non-electrical quantity. Option 4 is going to follow. In 32nd question, what they have given is, arrange the power amplifiers according to their angle of conduction. You just go through the previous year question papers, how many times they have asked. It's very much simple to remember. Look at the things. First you will be having class A amplifier, then class B amplifier. In between you will be having class AB, followed by class C, then D. Like this you will be having. What is the conduction angle in the case of class A amplifier? Complete conduction, 360 degree. In the case of class B, it is a 180 degree. So this in the case of AB, if I am writing, it will be between 180 degree to 360 degree. Between 180 degree to 360 degree. What is the conduction angle in the case of class C amplifier? Means it is less than 180 degree. Roughly it will be 80 to 120 degree. That's it. What is the conduction angle in the case of class D amplifier? It is 0 degree. So based on that, this, if I am solving, class A will be having the highest conduction cycle. So B should come first. Which and all options I can eliminate? Option 2 and option 4 can be easily eliminated. B should be followed by which one? A. B should be followed by A, right? So based on this, if I am solving, option 3 is going to follow. Option 3 is going to follow. Very, very important. 33rd question, look at the things. Arrange the settling time. Such a simple question they have asked. Look at the things carefully. Which is the best system? We know that critical dam systems are the best system. But designing critical dam system is like walking on a rope. We don't know when we fall. Right? So in most of the cases, critical dam system is not going to prefer. Why? Chances of tending to instability is very, very high. Right? So in the case of under dam system, the response will be something like this. In the case of under dam system, the response will be something like this. Now look at the things carefully. In the case of undamped system, you will be having a response which is something like this. Nothing but constant frequency and amplitude you will be having. What will be the settling time in the case of this undamped system means infinity. Undamped system means, in the case of undamped system, the settling time will be infinity. Nothing but oscillation will never die. So in the case of underdamped system, you will be having an oscillation and that is going to die. In the case of critical dam system, system response is something like this, quick response. But look at the things carefully. In the case of overdamped system, you are going to get a response of sluggish response or slow response. You're going to get sluggish response or slow response. Nothing but you'll be getting something like this. Slower response you will be getting. So look at the things. Let us try to arrange the things carefully. Arrange the settling time in decreasing order they have given. So in decreasing order, if I am specifying, which one will be coming first? See, faster system response is which one? Right? Critical dam systems are faster. Right? Then it is followed by under dam system. Then it is followed by over dam system. Then it is followed by undamped system. So in UGC NET, what is the key answer they have given means it is a CBAD. Unfortunately, this is not correct. Why? See, settling time we have to arrange in decreasing order. Nothing but which one is more? Settling time is more in the case of which one? Undamped case. So it should have been something like this, DABC. It should have been something like a DABC. But they are arranging from a lowest to highest. So this should be in increasing order. Question mistake is there and options also mismatch is there. Okay. 34th question, you see the noise figure of individual stages of a two-stage amplifier is, see, let me take F1 to be 2.03. F2 is 1.54. What is the gain of the first stage? Gain of the first stage is 62. Overall noise figure they are asking. Overall noise figure is given by what is the formula? In the fast track revision video also I have explained. F1 plus F2 minus 1 divided by G1. If you are thinking that you are in need of calculator, no, you don't require a calculator. What is the value of F1? 2.03 plus what is the value of F2? 1.54 minus 1 whole divided by G1 value is 62. Now look at the things. This is a 2.03 plus this is a 0.54 divided by 62. 0.54 divided by 62, which will be again a low value. 0.54 divided by 62, which will be again a low value. So based on this, if I am solving, which is the option I am going to get? Option 2 is correct. Nothing but 2.0547. In 35th question, what they're asking is the dielectric medium has a relative permittivity of 18 and the last tangent is a 10 power minus 3 at the frequency what they specified is 100 megahertz. Find the conductivity of the medium. What do you mean by conductivity of the medium? It is represented by sigma. That's it. Now look at the things. What is the significance of last tangent? See, last tangent is defined as a tan phi, which is given as, or it is expressed as, the ratio of conduction current to displacement current. Now this ratio, if it is greater than 10, then it is acting as a conductor. If it is less than 0.1, it is acting like an insulator. If it is lying between, it is a semiconductor. So these things we have to know. Now tan phi, which is given or which is expressed as a sigma divided by omega epsilon, or this tan phi is also rewritten as a sigma divided by what is the value of omega 2 pi f. What is the value of epsilon? It is epsilon naught times of epsilon r. If they have not specified epsilon r, you take it as 1, but they have given the value of epsilon r as 18. Now look at the things. Look at the things. They have given the frequency in hertz. They have given the frequency in hertz. So when you are expressing epsilon naught, it should be in terms of what? 8.854 into 10 power minus 14, not 10 power minus 12. Later on, if you want to convert into meter, easily you can convert. Now look at the things. What is the value of tan phi? Tan phi is a 10 power minus 3 into 2 into 3.1415 into what is the value of frequency? 100 mega. Mega means how much? 10 power 6 into what is the value of epsilon naught? What I told, 8.854 into 10 power minus 14 you are going to take, and what is the value of epsilon r? It is 18, which is equals to sigma, which is equals to sigma. Now what is the value of sigma you are going to get on solving? 10 power minus 6 mho per centimeter, but they're asking us to express in terms of meter. So what is the value of sigma? I'm going to get a 10 power minus 8 mho per meter. 10 power minus 8 mho per meter. Which option? Option 2 is going to follow. 36th question, what they are asking is, when S1, S2, S3 are the blocks which are connected in cascade to form a new system as shown below. Consider the following statements. See, what they are asking is, if S1, S2, S3 are linear, then S is considered to be a linear. See, S1 will be having a response of X, S2 will be having a response of X, S3 will be having a response of X, club it together X cube. No, X cube is not a linear system, right? So first option somewhere, if you are going through, it will be a wrong option. Next, S1, S2, S3 are non-linear. Okay, then S is said to be a non-linear system, of course. Now look at the things. This S1 system will be having a response of X, then S2 system will be having a response of X square, then S3 system will be having a response of X cube, then the overall system will be having a response of X power n. Like this you will be having. So I can tell then the overall system S will be having a non-linear functionality. See, what do you mean by causal and right-sided signal? Important. See, right-sided signal and causal, you see, in the case of causal, it should be from 0 onwards. It should be from 0 onwards, and it is right-sided. It is right-sided. But if I am telling only a right-sided signal, see, this is also right-sided signal. This is also right-sided. This is also right-sided. So all causal systems are right-sided signals, but all right-sided signals are not causal system. Very, very important, right? If X1, S2 and S3 are time invariant system, then S is also considered to be a time invariant system. Time invariant system is correct. So the corresponding option that is going to follow is which one? Option 2 is correct. Nothing but BCD is going to be followed. Option 2. Arrange the following semiconductors in decreasing order of band gap. This question is important. We have to remember, or we have to directly remember, the band gaps of few materials. In the case of aluminum phosphide, the band gap is 2.45. See, this question, if you're thinking it is very much difficult, it is the deadliest easy question. Why? We know that the band gap of carbon is more. That's it. You'll be getting the answer. See, what is the band gap of carbon? It is a 5.5 electron volt. Right? More, it should be from C side. Right? So, in decreasing order, first it should be B. See, you'll be getting answer as option 2 is correct. Why? Because of carbon you can able to solve it. In the case of cadmium selenium, the band gap is 1.74 electron volt. Gallium nitrate, it is a 3.4 electron volt. PBT, it is 0.32 electron volt. Least in the case of PBT, more in the case of carbon. If they would have given a B as a first choice, like multiple option consisting of B as first choice, then you are not in a position to opt for the correct answer. But in this, B is only available in second option, so you can choose wisely. So the corresponding option that's going to follow is option 2 is correct. In 38th question, what they have given is, in the case of solar cell, IL current they have given to be 100 milliampere and IS equals to 1 nanoampere. Then the open circuit voltage will be. We know that the solar cell is going to operate in fourth quadrant and photodiode is going to operate in third quadrant. And in the case of solar cell, we have to talk about fill factor, and in the case of photodiode, we are going to talk about responsivity. And we know that the open circuit voltage that is derived from solar cell is a negative value, or negative voltage you're going to get. So which is given by minus n k t into a ln of is divided by il, and we are going to express this quantity in terms of volts. So divided by q. See, in this, the value of n is approximated to 1 and k is referred as a Boltzmann constant, that is 1.38 into 10 power minus 23. And we are going to take, or we are going to derive this temperature, or we are going to take room temperature into consideration, that is a 273 plus 27 degree Celsius, which is equals to 300 degree Kelvin. So always you have to express in degree Kelvin only. So it is multiplied by 300 into ln of, what is the value of is? You will be having 1 nano. 1 nano means 1 into 10 raised to minus 9 whole divided by, what is the value of IL? The value of IL is 100 milli. 100 into 10 raised to minus 3 whole divided by 1.6 into 10 power minus 19 you're going to get. See, when you solve these thing, you're going to get a negative value. This negative into negative will become positive value, and this value will be equals to 0.482 volts, which is option 4 is going to be valid. Option 4 is correct. Now look at the things carefully. I don't know how you are going to solve this question without calculator. So some of the questions will be asked in all the exams, where you should go for blind guess, or like, are we in a position to remember these things? See, 10 power minus 9 whole divided by 100. See, this one I can write it as 1 into 10 power minus 5. So that minus 5, if I am sending it on the numerator, it will be ln of 10 power of minus 4. That 4 you are going to kick it outside, and then you're going to manipulate, and then you're going to get the answer, right? So for this 38th question, the corresponding option that's going to follow is option 4 is correct. Okay. Now this question I have solved in MCQs. Also, while explaining the antenna topic, I have explained these things. Now if I am talking about a radiation resistance in the case of lambda by 2 dipole. What do you mean by lambda by 2, lambda by 4, lambda by 3, all those things let us discuss later. But as of now, you just remember a radiation resistance. A radiation resistance in the case of lambda by 2 dipole. See, in the previous years also they have asked, match the following. Radiation resistance equals to 73 ohms they have given. For which antenna, you should remember only the antenna name, that is like in which dipole if they are asking, it is lambda by 2 dipole. In the case of lambda by 2 dipole, it is having a resistance of 73 ohms. It is having a resistance of 73 ohms. That's it, you will be getting the answer. Now, in the case of wire antenna, it is a lambda by 2. In the case of reflector antenna, it is a parabolic. In the case of antenna arrays, it will be high directivity. So for this, the corresponding option that is going to follow is option 3 is correct. In 40th question, the Z parameters based question they have asked is the simplest one again. Now look at the things. Looking at the circuit, are we in a position to say that the input port impedance is the same as output port impedance? Nothing but Z11 which is equals to Z22. The moment I say Z11 equals to Z22, you tell me whether the circuit is symmetrical or not. Yes, the circuit is symmetrical. The circuit is symmetrical in nature. Now look at the things. The impedance that is seen from port 1 to port 2 and from port 2 to port 1 is the same. Nothing but Z12 which is equals to Z21. What I can tell, are reciprocal in nature. The circuit is a reciprocal in nature. Very, very important. So the circuit is a symmetrical as well as a reciprocal. Right. In the case of Z parameter, what is the equivalent equation you are going to get? So in the case of Z parameter, V1 equals to Z11 times of I1 plus Z12 times of I2. Similarly, what is V2? Z21 times of I1 plus Z22 times of I2. Z22 times of I2. Right. Now, in this, say suppose if I2 equals to 0, what I'm going to get? V1 equals to Z11 times of I1 and V2 equals to Z21 times of I1. Now, based on this assumption, let me solve it. I'm putting I2 equals to 0. The moment I2 is 0, the current I2 is 0 means this I1 will be splitted up into I1 by 2 and this current will be I1 by 2. Right. So look at the things. The current will be flowing from 4 ohm and then 8 ohm. Here the current will be flowing from 8 ohm to 4 ohm. Same. So what is the current or what is the impedance I'm going to get? That is Z11 which is equals to V1 divided by I1 which is equals to what is the impedance that is seen in both the paths. It is 12 and in other path it is 12. How they are connected? In parallel. What is 12 in parallel with 12? Which is 6 ohms. Very, very important. So you are seeing from input side. Similarly, if you are seeing from output side, that is Z22, at that time you substitute I1 equals to 0, then this I2 will be splitted as I2 by 2 and I2 by 2. So in that one also you are going to get 6 ohms. So I am going to write directly as Z11 which is equals to Z22 which is equals to 6 ohms. So Z11, Z22, 6 ohms. Option 3 is correct. Now I want to find the value of Z12 and Z21. I want to find the value of Z12 and Z21. Now look at the things. Look at the things carefully. The another way is, see directly, we know that it is a lattice network. Z11 is given by ZA plus ZB whole divided by 2. See, this is the value of ZA, and these values are ZB, and this is ZA, right? ZA plus ZB divided by 2. What is Z21? ZB minus ZA divided by 2. That's it. So like this also you can find. Now look at the things. Apply KVL to the output loop. What I'm going to get? V2 minus ZB divided by 2 times of I1 plus ZA times of I1 whole divided by 2, which is equals to 0. Right? Now look at the things carefully. V2. I'll be taking this I1 terms on the denominator, which is equals to ZB by 2. If I'm sending these two terms on the other side, what I'm going to get? ZB minus ZA whole divided by 2. That's it. So V2 divided by V2 divided by I1 is what? Z21, which is same as what? Z22. What is the value of ZB? 8. What is the value of ZA? 4. 4 divided by 2 is how much? 2 only. So the value of Z12, which is same as Z21, which is equals to 2 ohms, which is equals to 2 ohms. I'm sorry, this should be Z12. Z12. Very, very important. So based on this, if I'm solving, the answer is option 3 is correct. Option 3 is correct. Very, very important. Question number 41, you see, match the following. Such a simple question they have asked. A programmable interrupt controller 8259. Universal synchronous asynchronous receiver transmitter 8251. Keyboard or display controller, it is 8279. Programmable internal timer, it is 8254. So based on this, if I am solving, which option is going to follow? Option 4 is correct. 42nd question, you see, which of the following statements are correct for N-channel MOSFETs? In the case of N-channel, the holes will be acting as current carriers. It seems no. In the case of N-channel, electrons will be acting as current carriers. In the case of N-channel MOSFETs, it will be having a larger transconductance than a P-channel. It is correct. It is having a more noise. No, the mobility of holes is less. So the noise generation is more in the case of P-channel. Has a higher or larger mobility than a P-channel. Yes, N will be having or the electrons will be having the larger mobility when compared to holes. So based on this, if I am solving, B and D is correct, nothing but option 3 is going to follow. Option 3 is going to follow. 43rd question, you see, in the case of frequency modulation, you will be having a bandwidth based on Carson's rule, which is given by what? 2 into beta plus 1 times of FM. What is the value of beta? Delta F divided by FM. Delta F divided by FM. Important. In the case of DSBSC, so here for A it is 3. For A it is 3. You got the answer. So what is the answer? Option 1 is correct. In the case of DSBSC, you're going to make use of Costa's receiver, right? You'll be having a problem of Donald Duck voice effect, in which modulation you will be having these errors. Already in analog communication revision video, I have explained these things. In the case of pin diode, it is used as a photodetector. Optical communication uses a wavelength division multiplexing. Right? Already discussed. In the case of photodiode, you will be operating in third quadrant. In the case of solar cell, you are going to operate in fourth quadrant. 44th question, you see, is such a simple question. Again, they have given, try to convert into small signal equivalent circuit and then you try to solve it. Now look at the things. This is a gate terminal and this is a source terminal and this is a drain terminal. What is the potential you will be having? It is a VGS. Now what is the value of VGS in this? You will be having what? V1. You will be having V1, right? you'll be having V1. They have given it as minus plus, so you can take it as minus V1. There is no one to object you, right? And moreover, in the case of a small signal analysis, what you are going to do is all the DC sources should be de-energized. So nothing but you're going to short circuit it. The moment you try to short circuit, it will be de-energized. VDD is also de-energized, right? Between D and S, between drain terminal and source terminal, you will be having a current source. What is the current source? Means it is a GM times of VGS. And again, look at the things. You will be having the resistance. What is that resistance you will be having? This RD. RD is connected between a drain and another end is ground, but source is connected to ground. So both are same. And you will be having the internal resistance, that also you have to represent, and that is RD. Now look at the things carefully. What is the value of V0 you are going to get? See, straight away I'm going to write the equation V0 equals to, in the case of common emitter or in the case of common source, you'll be getting the gain as a negative only. They have given positive, means the option is incorrect. That's it. So it is a minus GM times of what is the equation you'll be having? Minus GM times of RD in parallel with RD. What is the value of GM? GM is 2 milli into, what is the value of RD? You're going to get 10 kilo in a parallel with, what is the value of capital RD? It is 50 kilo. No need to write that kilo. Whatever the answer you're going to get, append that kilo to it. That's it. 50 in parallel with 10 means it is 8.33. And now look at the things. A kilo, if you are writing, that kilo is going to get cancelled. Why? Already GM is in the order of milli. So this milli and kilo is going to get cancelled. So what is the value of V0? V0 will be minus 2 times of what I told. This answer is 8.33. Nothing but V0 equals to minus 16.66 volts. Which option? Option 2 is correct. What is the value of R0 you are going to get? See, if you want to find the value of R0, start looking from V0 terminal. All the voltage sources need to be de-energized and all the current sources need to be de-energized. When V1, which is equal to VGS itself is 0, GM times of VGS is 0, nothing but current source is behaving like an open circuit. So you'll be having what? R0, which is given by what? How your RD and RD is connected in parallel. So what is the equivalent value? Already we have solved, which is 8.33. Append a kilo to it. That's it. So the corresponding option that's going to follow is option 2 is correct. 45th question, you see, we have to arrange the interrupts of 8086 in some order, right? Decreasing order of their priority they have given. Now look at the things carefully. The moment you press a reset, whatever may be the status, it has to execute that reset command. So a reset will be given the highest priority. Very, very important. Reset followed by, you'll be having internal interrupts. So the corresponding option that's going to follow is option 3 is correct, right? Now it should be followed by software interrupt, then it should be followed by hardware interrupt, then it should be followed by non-maskable interrupt. In the case of a decreasing order, if I am arranging, look at the things carefully. Hardware interrupts will be having the lowest priority, right? Hardware interrupts will be having the least priority. But you please consider non-maskable interrupt also they have given at large. Whether this question is valid or not, you ask yourself. Next question, you see, they have given a passage. So based on the passage, we have to solve some of the questions. You pause the video and you try to go through this passage. The phase constant beta of a lossless transmission line is given as beta equals to omega times of under root of LC. In which case you will be getting beta equals to omega times of root LC. Already I have discussed in EMTL video. If you have not watched that video, links again I am going to give in the description, or else you can click on the I button. The voltage standing wave ratio VSWR rho is given by Vmax divided by Vmin. Right? The rho is going to vary from 0 to infinity, whereas the transmission coefficient gamma, which is going to vary from -1 to +1. This range is very, very important. You please go through it. So for the 47th question, answer is option 1 is correct. 48th question, the characteristic impedance Z0 of a transmission line is given by. See, in the case of transmission line, they are given in terms of Z0, but in the case of waveguides, they are going to express in terms of eta. Such a simple change, that's it. See, if you are knowing waveguides, transmission line will be dead easy. Only the thing is the parameters you are going to change, that's it. Here you are going to represent it as a Z0, there you are going to represent as eta naught, that's it. Nothing else. So this Z0 is given by under root of R plus j omega L all divided by G plus j omega C. But under ideal scenario, what you're going to have means R equals to 0, which is equals to G. So what you're going to get, Z0 equals to under root of L by C. This is not valid in all the cases, but under ideal scenario, this Z0 is expressed as under root of L by C. In order to confuse you, first option they have given it as under root of L by C. The moment you try to opt under root of L by C, your marks will be deducted. So the characteristic impedance Z0 of a transmission line is given as under root of R plus j omega L divided by G plus j omega C. Very, very important. 49th question, again this question is based on logic design or digital electronics. You please go through it. Now look at the things. If I want to discuss this question is based on multiplexer. We should know the operation that is involved in multiplexer. See, S1, S0 are the select lines. Which input should be driven to the output will be based on select lines. If S1 and S0 values are 0, 0, then output Y is driven with the I0 input. When my select line values are 0, 1, then I1 input or I1 value will be driven to the output. Similarly, when the select line, I'll be taking it as 1, 0, then I2 value will be driven to the output. When the select line inputs are 1, 1, then I3 value will be driven to the output. So you will be having 2 power n inputs, n select lines, but only one output. Right? Able to follow? For a 4x1 multiplexer, what shall be the output if A equals to 0, B equals to 1? A is 0, B is 1. Nothing but which case? 0, 1. In the case of 0, 1 case, what will be the output? The output will be I1 data. See, what is I1 data? C given to a NOT gate, it is a C bar. So which option? Option 4 it is going to follow. 50th question, the last question. Till now, if you have not liked the video, please give it a big thumbs up. Now look at the things. For the given 4-bit even parity checker circuit, for x equals to 0, y equals to 1, these cases they have given. Let me try to write the truth table for XOR gate. You will be getting the answer. That's it. A, B are my inputs. Y is my output. Don't get confused with respect to this Y and this Y. Or you are having a confusion, I can change the parameter. I can write this one as M. When my inputs are 0, 0, output of an XOR gate is 0. 0, 1, 1, 0. In this cases, output will be 1. When all the inputs are same, then output will be 0. Inequality detector. XOR is inequality detector. That's it. Right? So based on this, let us solve. If x equals to 0, y equals to 1, first case, then z equals to 0, p equals to 1. Now look at the things. 0, 1 given to an XOR gate, what is the output? 1. 0, 1 given to the XOR gate, what is the output? 1. 1, 1 given to the XOR gate, what is the output? 0. What they are expecting, C is 1 they are telling. So first option is wrong. First option is wrong. Let us get into second option. Let us get into second option. Let us get into second option. In the second option, what they are given is x is 1, y is 0, z is 0, p is 1. 1, 0 given to the XOR gate, what is the output you are going to get? 1. 0, 1 given to the XOR gate, what is the output you are going to get? 1. Now look at the things. 1, 1 given to the XOR gate, you will be getting 0. 1, 1 given to the XOR gate, you will be getting 0. So what they are expecting, C is 1. So second option also can't be. Second option also can't be. Second option also wrong one. In the third option, you see x equals to 1, y equals to 0. Z is 1, p is 1. Look at the things. 1, 0 given to the XOR gate is 1. 1, 1 given to the XOR gate is 0. 1, 0 given to the XOR gate is 1. So C is 1. Yes, option 3 is correct. So based on this, if I am solving, which option it is going to follow? Option 3 is correct. Option 3 is correct. Able to follow? So friends, in the part 2 video, I have covered from question number 26 to question number 50. In the part 1 video, I have covered from question number 1 to question number 25. In the next part of the video, I'm going to discuss from question number 51 to question number 75. If you have gone through the solution and if you have understood with the solution video, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you.